Hi, I'm bestfitting. In this video, I will introduce my third-place solution to the SIIM ACR's competition. This is the pipeline of my solution. I use the UNet to predict the nonce in an X-ray image. Then I cropped the nonce from the image to save memory and computation resources. The cropped images were fed into a SIIM UNet to predict the pneumothorax, and then the predicted masks were restored and resized to the original size. Now let's have a look at the non-segmentation UNet. I use the NLM Montgomery CXR set as a train set. This dataset contains 138 samples. This is a small dataset, but the non-segmentation result is good enough for this competition. This is a simple UNet based on ResNet 34 with CBM attentions on decoders. I trained it on small-sized images, as we don't need too precise predictions of nonce. By doing so, we can cut off about 40% of areas of an image. It's very important to make full use of the external dataset in this kind of competition. We can use many large datasets such as Checkspert, but they did not provide segmentation labels, so I tried to adopt pseudo-label strategy. I first trained the ResNet 34 UNet to predict the masks of the positive samples of Checkspert. The predicted positive samples were then treated as positive pseudo-samples. The competition dataset and the Checkspert images were corrupted by using the UNet I introduced before, and then were fed into a SIIM UNet. I oversampled the positive samples to keep the positive and negative samples were equal in every epoch. The pseudo-label samples were sampled to be half of the competition samples. This is my best model. It's a SIIM 50 UNet. I used the CBM attention on every decoder and upsampled the feature maps of the decoders and concatenated them as a feature map to predict the masks. The technical details of the network are here. I did not use classification model and did not search threshold to avoid overfitting. And a 3 of 10 folds of this model can get 0.864 on private leaderboard. This is almost the same score as my final submission, so it's not necessary to introduce other models furthermore here. Okay, this is my solution to the interesting competition. Thank you.